All right, let's go ahead and get started. So, hi everyone. My name is Jason Frugier. I'm in here from Dallas, Texas, and first time in Toronto. Absolutely love it. Spent some time yesterday walking around the city. Very impressive place. Lots of friendly people. It was a good time. So I'm glad to be here, and I'm glad that all of you decided to join this session. I know you had a lot of other sessions you could have gone to. So thank you for attending. Hopefully this is a valuable session for everyone. Today we're going to talk about proactive threat hunting with continuous exposure management. I will introduce myself really quickly. My name is, as I said, Jason Frugier. I'm the resident CISO for XM Cyber. Prior to joining XM Cyber, I was the CISO for the Upbound Group. Prior to that, the Fossil Group, they make the watches, Signet Jewelers, Sterner Healthcare, and I was global head of infrastructure security for Citibank for a number of years as well. I am excited to have joined XM Cyber. XM Cyber solves a problem that I personally was frustrated with throughout my career, which has to do with prioritization and has to do with what I think today is more of a problem than ever before, which is how defense in depth is kind of falling behind, how it needs to be refreshed, how attackers weave their way through our layers of defense, and what we can do about that is a problem that XM Cyber addressed. So today we're gonna talk about how to get the most risk reduction with the least amount of effort. And to do that, you don't start with a better vulnerability scanner. Instead, you start with proactive threat hunting and attack path analysis. Let me just to set the placemat for that, I like to use the cyber defense matrix. How many people have heard of the cyber defense matrix? It's a popular tool. I've overlaid it with the boom diagram. The boom diagram is a useful tool I've used throughout my career as well, where the boom is like a security event or security incident. And guys, feel free to take pictures of these slides, no issues at all. With the boom being the incident, everything to the left of boom is preventative and proactive. Everything to the right of boom is response and recovery, and all happy security practitioners live left of boom, right? We live in that proactive space. And so whenever I've evaluated technologies, I've leveraged both of these frameworks to say, where does that technology fit in the identify, protect, detect, respond, recover phases? You can recognize that from NIST. And then in the asset categories, devices, applications, networks, data, users, and identity. And this was what Sunil Yu, who's the person who invented the cyber defense matrix. Sunil is a data security scientist at Bank of America. And he was challenged with all these vendors coming to him all the time saying, hey, we can address all your problems. And he would say, well, where do they fit rationally? And so he created this table, which is simple to look at, but it really tells a good story whenever you're trying to invest in something. And when you fill this out with all your controls, and by the way, if you ever do fill one of these out, you're going to have 50 to 150 controls in there. It's going to be a much more filled out table. I just put placeholder data in here for illustrative purposes, right? But it's useful to see it this way, because the problem that I think that jumps out at me when I look at this, as you can see in the asset categories, the devices, applications, networks, data, and users, is we get what I call silos, right, of information. So for example, in the device silo, we've got vulnerability scanners and MDMs that look at like devices and they say, show me your missing patches and config issues specifically on devices. And then we prioritize with that data based on other missing patches, right, and vulnerabilities and so on. If we jump down to users and identity, it's the same problem. Identity data is looked at in the context of other identity data for prioritization. But it's very difficult, and that's true for application API, data security, all of those are silos, and it's very difficult for us to say, how do we prioritize fixing a CVE, because there's also an identity issue on that system, which would allow someone to use those interconnected exposures to advance into our network. How do we do that? And to add to the complexity of that, some of those issues, and I don't mean to just pick on identity, but it is one of the most dynamic things in our environments, where identity issues like cached credentials are changing all the time. Somebody might have just logged in and dropped a pre-shared key to your Amazon environment on this print server inadvertently, right? And how do you know that happened unless you're continuously looking for that? And then, hey, that print server also has a CVE, that's an important one that someone could break in. and then use that pre-shared key to jump into my cloud environment. So that's obviously a more important fix than all the other vulnerabilities, right? But if I don't have that interconnected view, it's very difficult for me to see that and to prioritize. So, it's important to be able to put a view together that shows across all of those different asset categories what that exposure really looks like. How is someone going to get into my environment? And, I like to say, attackers today don't break in, they log in, right? It's a phrase I say a lot. And when people log in, it's one of the most difficult types of attacks to detect because login activity is expected. They're using a legitimate credential or a key. It doesn't look like it's suspicious when they're using that information. So people can sit in environments for days, weeks, months, sometimes years, undetected, and threat actors know that. And so it's increasingly, the IBM report there shows 71% year over year increase in the frequency of using credentials for breaches, right? So it's an ever-growing problem, and it just continues to get more and more challenging. So it's important to shift. We want to shift away from that siloed view and move to a more comprehensive, holistic exposure management view. We're going to talk about how to get there, but this is very important. How many people do threat hunting in their organizations today? Fantastic. I mean, threat hunting is really the key, right, to try to get in front of these things. And so breaking down those silos and then adding that business context to that threat hunting activity is critical. And what I mean by that is identifying what assets matter most to your organization. Like, does this system contain customer data? Does this system contain my ERP? And so on. That's critical and it's key because as you do these threat hunts, those attack paths that get to those critical assets should be prioritized higher than attack paths that do not. So we'll jump into some of the pillars of exposure management. Obviously, comprehensive asset discovery and categorization. I like to, and I traditionally leveraged business continuity plans to help me find what are the critical assets, because that usually begins with a business impact analysis. And so like a business continuity plan or business impact analysis specifically will say, here's the most critical functions our business performs, right? So whatever your business is, whatever you're in, if it's retail, it might be replenishing your store shelves. This is a critical function. It's supported by this application. Therefore, that application is very critical, and so on. So you glean that data from there. So gathering that information, using that in the context of threat acting is critical. Also critical to have a multi-factor vulnerability assessment. Basically, not just CVEs, right? We need to add other types of exposures, such as identity issues, runtime memory, what's running on the system, malicious files. I talked about pre-shared keys. All of those things are exposure types beyond just like patches, and putting that data together is critical. The attack path analysis and threat modeling, thinking like an attacker, right? I'll jump into that in more detail in a moment. The business impact quantification, right? What's the real world cost of a breach, right? This is good data to have as well for exposure management. And then security control monitoring. Are your defenses working effectively? That has to be tested. In the threat hunting that you're doing today, hopefully you're finding the ability to test your security controls as part of that process, baked into that process, an effective part. So I want to talk at this point about digital twins, because I think an exposure management program leapfrogs ahead of every other exposure management capability when you implement a digital twin. Does anyone use digital twins today, or are you familiar with digital twins? I love talking about this topic. It's a cool topic. It's an emerging topic. I feel you're going to hear about this more and more in the future. So a digital twin is a replica of your environment. This is something that NASA actually created during the Apollo space missions. This was the first digital twin. And what NASA did is they realized that when they started having conversations about the challenges that they're facing, trying to fly from the Earth to the moon, it was hard to have 2D conversation, right? It was hard because every time they'd get a little bit further, someone would bring up something else, and it was just, they weren't making progress. So they eventually just created a model of the moon and the Earth, and they flew a spaceship on a stick, and then they started adding all the complications, and I'm out of my depth when I talk about this, by the way, but all the complications that happened between here and there, and it was able to get a successful space mission. Today, we have companies looking at that capability, and they're using it, right? So, for example, research hospitals will sometimes use digital twins, and it's becoming more popular. If they're doing a surgery on a patient that's an advanced procedure that maybe has never been done before, or this particular procedure on that particular patient is very difficult, they'll create a twin of the patient, and that twin will have all of that person's, whether that person has high blood pressure, allergies, whatever that looks like that's unique about that patient is factored into that replica or that twin, and then that surgery is performed on the twin. And if it's unsuccessful and it kills the twin, they can adapt it and try again. And if it still kills the twin, they keep adapting it until they get it right. And then they have the best chance of success when they go to do the actual surgery on the patient. I love this topic. I talk to a lot of people in the digital twin space. And one of the guys I was talking to works in construction, and they're building a stadium. And they took the 3D plans for the stadium, uploaded those into a twin, and they're running scenarios. So in their twin of the stadium, they can say, what does it look like during halftime, right? This is a football stadium. What does it look like during halftime? How do people get food and get back? What's the timing on that? So that's one scenario. Another scenario, what about the game's over? How long does it take to clear out the stadium? What about a bomb threat, right? Do we have stairs in the right places? Do we have elevators in the right places? Do we have bathrooms in the right places? So they can run all these scenarios before they start pouring concrete. They run all these scenarios, and they know that they're building an optimally designed stadium, right? So we see over and over again, advanced problem solving is accelerated by the use of a twin. Now, I think in IT and what we do, I think we're going to see continuity testing start to use digital twins. I think we're going to see tabletop exercises. I mean, imagine how much more fun that would be if you could actually give your company ransomware and then work in a twin to try to stop it. So I think we're going to see this more and more. In the context of exposure management, creating a replica of your environment, and I've created a replica here visually, allows you to start running pen tests, right? Simulated pen tests, just like a simulated surgery. You're running these penetration tests on that exposure data, and in that twin, you have those critical assets all mapped out. So in that corporate network is their SAP system, and that cloud environment is an S3 bucket with customer data. All these things are identified in that twin. And as you run these pen tests, you start to see these attack paths where someone took a vulnerability here, they harvested a credential, they used an SSH key reuse there, right? And they created some access in the environment. You start to see all of these things, and you have an opportunity to see where did that attack path begin, right? And now with this prioritization, you can say, hey, we have 10 beginnings for these attack paths. If we just fix these 10 things, those paths are all broken, right? So from a priority perspective, you can say, hey, if there's only 4 or 5 things that we can do today, it's these, right? And if you're doing this continuously and a new attack path pops up because some bad behavior, some key got cached, or some new exposure was identified, you can react to it. When I was the CISO at the Upbound group, you guys remember Log4j? Show of hands. That was one of the last, before I left Upbound group, that was one of the last major CVSS 10 issues that I faced. And while I was there, I had 2,000 instances of Log4j exposures. It's a lot, right? It's a lot for anyone. And the only way I could prioritize was if it's externally facing, we're going to go after those first, and then we'll fix the inside one second. But it's all CVSS 10, so we got to get this done in a week. And it was, so I'm walking into my CIO's office, and I'm like, hey, what are you guys working on? Right? Let's drop all that. I got to get on, it's a terrible, nobody wants that conversation, right? You see the joy just wash away from the CIO's face. So we ran a scenario through here, through our digital twin, where you have these 2,000 Log4j exposures, and you can run that, and you can go, okay, show me all of the instances of Log4j that allows for forward movement across the entire estate. You get a number like 15, 16, right? Based on our data, usually about 85% of CVEs are dead ends. If somebody does break in, they can't go anywhere, right? But because we don't have that intel, we don't know. So we can't say with certainty, so we have to react to the CVSS10s like they're all emergencies. But they're not all emergencies, but we just don't have a way to test them fast, right? And so we end up spinning a lot of wheels. That's another advantage of a digital twin is you can run scenarios like that and say, actually, these are the ones we need to fix today, and then we can all go home for the weekend, right? That'd be nice. So it's a powerful capability. Doesn't mean you don't want to fix the other ones, but you can smartly deprioritize them because you know they're not really a threat to your company, right? So like I said, it's a powerful capability. So I'm gonna let this play out, sorry. There's a lot of, there we go. So the blueprint for proactive threat hunting, as I mentioned first, is get the right data, right? The right data includes vulnerability data, identity, runtime memory, pre-shared keys, cloud security posture data, asset management data, threat feeds, intelligence feeds, understanding the latest TTPs. This is all critical, all very critical. Map those attack paths and then prioritize based on business impact. I want to tell a story real quick because I think the urgency is greater than ever here. Is anyone here familiar with the XBOW project, XBOW? This was a it's pretty current, but there was a couple of guys who decided to prove out a theory. And their theory was, is it possible to create an offensive AI bot that is better at hacking than a human hacker? And so they set out to create an agentic AI bot. They called it XBOW. And once they had it created, they said, how do we test this to prove the theory? So they joined the HackerOne network. And for those of you that don't know, HackerOne, that's a subscription service where your organization can join. It's a white hat hacking service where hackers all over the world are part of the community. They get to hack in your environment, and in exchange for finding these bugs, they get a bounty, right? So you set a bounty with them. If it's a high, you might pay them $1,000, a medium $500, whatever, but you pay them a bounty. So XBOW joined the HackerOne community, and the HackerOne community, they create a gamification system, so they have leaderboards. So like if you're the guy finding or gal, whether the hacker finding the most vulnerabilities, you get to be number one or number two or number three on the list, so it makes it competitive, and it's kind of fun for the community. So XBOW joined and got kicked out because HackerOne requires peer reviews. And so then they had to go create a peer review bot. It's kind of funny. I would encourage you to go read about XBOW. And I don't think anyone would be surprised to know that once they finally got the peer review bot in place and the other stuff, they became number one on the leaderboard. And they stayed number one on the leaderboard for 5 months. I was recently talking to someone there at XBOW, one of the guys, and they said 3 months, but I'm pretty sure I was watching it and it was 5 months. I don't know which story to believe. Maybe they're being too humble. But it didn't surprise me, and I don't know that it would surprise any of you, that this bot, acting by itself, got into this community and started targeting the customers. And because it's a bot, it doesn't sleep. It's relentless, right? The hard things, the hacks that are the most difficult, don't bother it. It doesn't get tired. It doesn't just look for low-hanging fruit like so many of us humans often do, right? It doesn't do that. It's doing all the advanced stuff, and it's doing it all day long. And it's finding attack paths faster than humans can. And when I think about that, and I think about what we used to call script kiddies, all right, these are like the untrained threat actors who just run scripts that they find on the internet. Well, when I think about that kind of a person who grabs a couple of XBOW-type offensive bots, now they're a superhuman hacker, right? Because they can just target your company with these bots, and they go to bed, and those bots just keep working, right? And it's like they're a Unit 8200 trained threat actor, only they're everywhere now. And this is actually happening. We've got other examples that I've seen of people using AI to enhance or augment their hacking capabilities. But you've got these threat actors now have the ability to find these interconnected vulnerabilities and find ways to weave through your defensive layers faster than you do today, right? Now imagine what we talked about with that digital twin and that continuous threat assessment. You can find that stuff faster than they can. And this is the game. You got to find that stuff faster than them and fix the right things faster than they can exploit those things. And so I think that the offensive AI capability has created urgency. The attackers have a new tool in their bag, right? And I don't think we can keep doing the same thing we've always done, just maybe more efficiently, and expect it to combat that. I think we've got to take on new capabilities too. So with this, what we're describing here, this is really giving you the ability to aggressively test every exposure in your environment all day long, right? So it's a powerful capability. So yeah, I'm sure you guys have read as I was talking some of these takeaways. XM Cyber, that's who I work for. We do continuous threat exposure management. We enable you to do everything I described, and I'd love to talk to you more about it. A lot of major clients depend, a lot of these brands are some of the biggest brands in the world. They depend on XM Cyber. We've been doing this since 2016. This capability has gotten stronger as we've been doing it. We were acquired by the Schwartz Group in 2021. Schwartz Group has 600,000 endpoints, so the fourth largest retailer in the world out of Germany. They bought XM Cyber. It's kind of a hair club for men story. They became a customer, and then they liked it so much they bought the company. And so that's who owns us. But we've got a lot of key technology partners and relationships. I'm very proud to be a part of this team. We are at booth 1025. I encourage you to stop by. We can do a demo of the product. We can continue the conversation there. But I'm happy to go ahead and pause now for any questions anyone might have. Pretty comprehensive? Oh, I'm sorry, I didn't see it there. Yes. It's up to you. I can hear you.
So the digital twin, is it, because I've seen like digital twins before in which a company would simulate one of their workstations of it. But would the one by XM Cyber be like a full-on corporate network, DMC, kind of this? That's a
great question. So for those of you that didn't hear him, it's essentially when we construct a digital twin, how complicated is that? Is this a big, huge footprint? I'm glad you asked that question. And actually, the answer to that is no. Part of the beauty of what XM Cyber did in creating that digital twin is the elegance of it. I mean, you can really think of it as a virtual, a conceptual database that has your exposure data in it. But it's not like we created a whole new data center with your environment in it. It's really like a logical construct that has just metadata about your exposure data that's in it. So it's proprietary format. It's got telemetry data in it, so it knows if this system can talk to that system or not. Like all of that's in there, and it's constantly updated. So the Schwartz Group, as I mentioned, had 600,000 endpoints. We pen test the Schwartz Group, I think 4 times a day, the entire company. 600,000 endpoints. We're doing that simulated pen testing or threat hunting 4 times a day. And anything that changes in that environment, it's updated in the digital twin, right? If any of that exposure data is removed, like they patch some things, we know that. If there's new identity issues, we know that. So it had to be designed in such a way that that digital twin can be created in minutes, right? So what we typically find when we go into a proof of concept or deploy with a customer, they start seeing things they didn't know about within 48 hours, immediate value. It happens very, very fast.
It's like a next generation threat modeling.
It is. That's 100% next generation threat modeling. I like that. I might use that. Oh, thank you. See me afterwards so I can put your name next to it. Other questions? Okay, well, again, my name is Jason Fruget. We're at booth 1025, just one floor down. I'd love to see you and continue the conversation. Thank you all so much for coming. I had a great time talking with you and good questions. Thank you.